So hello and welcome also from my side. Good morning, good afternoon to everyone. Where I would like to give you some insights to the connection of the largest paper mill to the power grid using process bus. But before we start, I'd like to invite you to view a trailer about the project as such. I hope you enjoyed the trailer. The extended version of the video is also available on YouTube, in case you like to share or watch it again. I will start my presentation with a short introduction, providing additional information to the trailer, share with you the applied solution and the technology highlights, with the project followed by a summary. Let's start with additional information to the UW Sandersdorf project. The UW Sandersdorf substation is in eastern Germany and supplies electrical energy to one of the largest and most modern paper mills in the world. Due to the size of the plant, 50 MVA of installed electrical power is required. The overhead lines are connecting the substation to the 110 kV grid. The layout of the substation is a traditional H scheme with 210 kV to 20 kV transformers and feeds the paper mill's 20 kV medium voltage switchgear. The distance between the high voltage and medium voltage parts of the substation is about 1000 meters. The challenge of the project was this distance between the 110 kV and 20 kV parts of the substation, as a large part of the paper mill is located in between, which means that the secondary cable trays run through the plant and traverse a harsh electromagnetic environment. Let's have a look on the applied solution of the project. The main protection for the switchgear requires protection of the lines to the 110 kV network by distance protection and of 110 kV to 20 kV power transformers by transformer differential protection. Additionally, all instrument transformers are directly connected to protection devices via coupled cables. The instrument transformers must be designed to drive the specified burden. How did the project planners master this challenge of the long distance between the high and medium voltage without endangering the electromagnetic immunity of the plant? The solution is to use process bus for parts of the substation. The picture shows the protection of the infeed to the 20 kV substation. On one hand, the 110 kV overhead lines are protected by a conventional connected line protection device. On the other hand, the 110 kV to 20 kV transformers are protected by a transformer differential protection device, with the primary CTs connected directly to the protection device and the secondary CTs located in the 20 kV substation about 1000 meters away through a merchant unit that digitizes the current signals as IC 6150 9-2 measured values. A bay control unit also hosts the automatic voltage regulator for the transformers and reduces the footprint of the protection and control system by concentrating functions. A small process bus network consisting of two Ethernet switches with fiber optic Ethernet cables connects the merchant units to the transformer protection and bay control devices, providing perfect protection from the harsh electromagnetic environment of the paper mill. This saved about 16 kilometers of copper cables and allowed smaller instrument transformers to be used in the medium voltage infeed base. The total cost of the project was similar to that of a conventional installation, with increased reliability of the system towards electromagnetic influences. In a nutshell, you can say 6150 process bus opens new ways to an optimal solution for your application. What are the technology highlights used in this project? The process network itself consists of 2 Ethernet switches arranged as PIP network. The special feature of the switches is the built-in IEEE 1588 Precision Time Protocol time source. This multifunctionality eliminates the need to install dedicated global navigation systems-based PTP time servers to provide the necessary high accuracy sample and time synchronization of process bus systems. The use protection devices allow a mixed measured value acquisition through directly to a protection device connected instrument transformers and subscription to them measured values. This functionality allows a tailor-fit measured value acquisition based on the site conditions. The process bus Ethernet network distributes beside the 6150 SAM measured values also binary information from and to the merge units via Goose, as well as the IEEE 1588 Precision Time Protocol telegrams. With the use of edition 2.1 of 61850, the latest revision of the 61850 standard was used, which provides certain very useful enhancements compared to previous revisions for process bus installations. One of these enhancements is the definition of the optional field for the grandmaster identity, which specifies the source of the synchronization within the sampled value stream. Furthermore, the standard strongly recommends the use of this field, even if it is declared as optional. In addition, the rated current, voltage and frequency settings have been declared from optional to mandatory, and other new mandatory settings were introduced to better maintain interoperability for process bus. One of these new settings, for example, is the setting secondary time constant, which describes the behavior of analog value acquisition. Since the UW Sandersdorf projects uses a single vendor implementation, those new mandatory and additional settings are not so important for the installation in these projects. However, due to their importance for the interoperability of a process bus across several manufacturers, I do not want to leave these edition 2.1 additions to the standard unmentioned. By the way, the CPTEC 5 devices were the first devices worldwide to receive certification by DNV, formerly KEMA, for 61850 edition 2.1. This certification now also includes subscription to SAMP measured values as well as publication according to IC 61869-9. As already mentioned, IC 61850 edition 2.1 strongly recommends the use of the PTP grandmaster identity field. The used CPTEC 5 devices are following this recommendation and providing with it a higher availability by independence from a global navigation satellite system, synchronized PTP time source. How is this achieved? The subscriber devices evaluate the sample synchronization information. In case of not traceable IEEE 1588 PTP time synchronization of a merge unit, the sampled values will be published as local synchronized. In the next step, the PTP grandmaster identity of the streams is evaluated. In case the PTP grandmaster identity is equal, it is ensured that the synchronization of the subscribed sampled values and protection device himself is done by the same source and therefore are operating on the same time base. Process bus does not require high precise global time synchronization. Important is the relative high accuracy. If operation on the same time base is given, there is no need to block any protection functions and get the backup protection functionality activated. This allows the protection system to stay in service also for non-traceable time synchronization, which could easily happen during bad weather conditions, for example. Please keep in mind that CPTEC 5 are the first devices worldwide certified by DNV to comply to 61850 edition 2.1, which includes also the certification of a sampled measured value publisher and subscriber. Whereby I'm at the end of my presentation. Let me summarize the key takeaways. In general, the cost effectiveness of a process bus installation versus a traditional installation strongly depends on the situation on site and the location of instrument transformers in relation to the protection devices. Fiber optic cables are excellent for mitigating the influence of electromagnetic fields. The possibility of a mixed connection of sampled values with directly connected instrument transformers for the protection devices is often the optimal solution. This integration of additional functions in IEDs reduces physical footprint and investment costs, such as the integrated PTP time source in the switches or the automatic voltage regulation function of the bay control units. IEC 61850 edition 2.1 allows independence from global navigation satellite system based PTP synchronization for sample and times. Therefore, increase the availability of protection, and I like to stress it again, because of the importance edition 2.1 ensure also proper protection operation in multi-vendor installations. With that, and my strong recommendation that 61850 edition 2.1 should be used in a modern process bus installation, I would like to share with you a statement from Mark Reschke, who led the technical protection concept for the UW Sandersdorf project.
Unsere Mitarbeiter haben eine innovative Anlage realisiert, die seit circa einem Jahr störungsfrei im vollen Prozessbetrieb arbeitet. Meiner Meinung nach wird diese zukunftsträchtige Technologie eine wichtige Rolle im Layout kommender Anlagen spielen.
Many thanks to Mark Reschke, and I can only confirm his statement. My personal opinion is consistent. I see process bus as a good complement to well-known and traditional concepts for protection applications, especially when a lot of copper wires can be eliminated. The process bus has its strengths to be the best solution, either as complete process bus solution or as a partial implementation, as it is the case at the UW Sandersdorf. With that, I like to say thank you for your attention and invite you to visit me on the expert booth. I will be there in a few minutes to answer also further questions which are not here in the audience now.
Thank you, Stefan. We already have some questions. The first question that was pretty early written into the chat there is, how is CProtec 5 better than other protection devices?
Oh, it's a good question, not really process bus related. But what makes our device superior to others, if we look at process bus, the process bus implementation is basically available on all of our protection devices, except the non-modular devices. This is a smaller portion of it. So this means any protection application can be realized with process bus, and it's a complete modular concept and can be used without any limitations here on the protection device side.
Okay. And then we have a next project-related question. Who was the vendor of the switches and for what reason were they chosen? And in brackets, it's PTP.
Okay. First question, who was the vendor? It's Ruggedcom. This is our most proven vendor, which we use for any 6150 projects where we don't have any limitations on what switches has been used. Those switches was also tested by our R&D to ensure proper operation. And you asked what is PTP? PTP stands for Precision Time Protocol, which is also the IEEE 1588 standard.
Thank you. I think that was a comprehensive answer. I almost got it, but I'm no expert in process bus and station automation at all. So that's okay. I just deliver the questions and continue with the next one. Have you used LPIT's sensors in the medium voltage switchgear? And you could avoid the use of separate bus bar voltage measuring bays. Okay. Do you? Okay.
Yeah,
you understand the question, I
understand
think.
the question, absolutely. It's a good question, and in that project, LPITs has not been used. They are great also on the medium voltage switchgear side, but at this time the project was executed now almost 2 years ago. There was no projects or no LPITs available. This is to come pretty soon from Siemens to have also LPITs on the medium voltage switchgear side, and this could be for sure a good solution on the medium voltage switchgear side.
Okay, thank you. Once again, or even I learned something. That's why I like this moderator job. So next question is coming from RS, and RS wants to know what was the bandwidth of the process bus, 1G or 10G?
So the backbone, the switches was 1 gigabit switches, which is for that small installation more than sufficient. We have seen we have 2 merging units here, which gives a bandwidth usage of about 12 megabyte. And the uplinks to the merging units was 100 Mbit. So this was more than over-designed, and a 10 gigabit backbone was not really required on that project.
Thanks. The next one is one question I can even take, because it's, is there any chance to download this presentation? And you will have the chance to download and access the recording of the whole presentation, because we think the additional value is on what Stefan tells us with the slides. And if you think you definitely need the presentation, give us an additional hint and we'll somehow find a way to make you happy with what we can deliver. The next one is one for you, Stefan, again. Why didn't you use also for the HV side, CTs and VTs, the process bus, and you preferred a classical solution? One reason is the distance, of course, but did you have any other reason?
Yeah, the main reason is really the cost position. As the transformer differential relay is pretty close to the transformer, and the cables are not that long. I don't know the exact number, how many meters it is, but it was not really worth to spend here additional merging units. With the copper cables we would have saved. That's why the primary side was connected directly and not via merging unit, but it would be possible as well.
Okay, so yeah, when you want to save copper, it makes sense to investigate an additional technology, but if we talk on short ways, yeah, let's keep it on a reliable our process bus is reliable, but the kind of standards no. Yeah. Thanks. Next question. We have some in the line. Here the process bus was made for special transformer application. So in this case, long distance. Do you have more installed process bus, LPTI projects, also called like digital substation projects? Sorry for jumping around a bit. I have no fear of wasps, but that was a little bit tickling. So, did you get the question, or shall I repeat it?
I think I got it.
Thanks.
It's about other process bus projects, what we have installed. And yes, we have a couple of more projects. Majority is conventional CTs, where we have projects in Peru, in India, in Vietnam, in Canada. But we have also a few projects with LPITs, which are on the transmission side on 110 kV. Together with Siemens Energy, we have developed here a merging unit to connect via LPIT, which has a Norkovsky coil and a voltage field probe to measure the voltage. And here also process bus was applied and used, and those installations are mainly in Norway and as well as in Iceland so far. But more is about to come.
Thanks. Then we have one question which I find right now is kind of difficult, because it's just who was the vendors, and it was asked around 10 o'clock, so somewhere at the end of the presentation. I mean, one of the vendors had definitely been Siemens. You already mentioned RuggedCom.
Yes.
Are there any more we need to mention?
I don't know that many details what other vendors has been used, but on this process bus installation it was Siemens as the protection devices, the Black 5 product line, and the switches was RuggedCom. Outside of that box I have not the information here. But if this is important, we can find out.
Yeah, I think so. So the question was from BH. So if you need more information on that, contact, for example, Stefan. I think you're active on LinkedIn, aren't you?
Yes, I am.
So that might be a possibility there to clarify on the question. The next question is some kind more detailed. Is it necessary to use the same IEDs in the process level and bay level supported edition 2.1 for arranging process bus?
We don't have too much experience on that. Edition 2.1 allows the interoperability or improves the interoperability drastically, but because of the lack of other suppliers with Edition 2.1 support, we don't have really experience with that. But our expectation is that this will work and operate. By the way we are doing right now, interoperability tests with other vendors, even if we are not supporting Edition 2.1, to see how this interoperability can be achieved also without having Edition 2.1 to not block our projects where interoperability is also asked and required.
Okay, thanks. And the next question comes from FO, and FO wants to know, is it possible to add a current sensor module for the 7SJ82 family?
That's a good point. So let's start. The 7SJ82 is from our non-modular device platform. And where is in the pipeline an LPIT module to connect that to LPITs. But for a certain time, Prosbus won't be coming to the non-modular devices. This has technical reasons, not that we don't want it, but it has technical reasons why this takes a bit longer. But down the road, also those non-modular devices will support Prosbus.
Okay, thanks. So we have more questions in the row. Thanks for addressing them to us. And the next one is, according to the presented material, how did you arrange trip signals between upstream and downstream intertripping from 87T protection? Once again, a very detailed question.
Yeah, so the trip signals for the medium volt switchgear breakers was transmitted via goose signals, means the protection device, the transform differential device, sends its trip decision via goose to the merging units, and the merging units operated the circuit breakers. And on the primary side, those trip signals was directly connected to the circuit breakers on the high voltage side and tripped there.
Okay, thanks. Then we have a thank you for answering the question. So I think people like what you answer. Thanks for that. And we continue this questions round. Is it okay to connect one side conventional transformers and other side LPIT for trafodiff, so transformer differential protection?
Yes, absolutely. This is also possible. So in the projects in Norway, exactly this was also being done. Also on the feeders for the transformers, primary side was an LPIT, and the secondary side was conventional CTs on the medium voltage side. Yeah.
Thanks. But we take one last question before we close this session, and this one is, can IEC 61850 protocol, especially GOOS, be combined with traditional protocols like IEC 104 protocol and improve the switching time of the relays?
I'm here also not sure what's the background on the question. Protocols can be also mixed on our devices. I don't know all of the combinations out of my head. But if I'm not mistaken, 104 protocol and 61850 can be used in parallel. I can check that up, and if you're in the expert group, I have also my documents in front of me and I can have a look which protocols can be used also in parallel.
Perfect, that's a great idea. So if you think the question is answered enough, then call it a day. No, join us in one of the next session, or make use of our expert being there available in the exhibition area. So thanks a lot for your question. We'll close the question round right now. Thanks, Stefan, for the presentation and for your time right here. Thank you for your questions. Thank you for your time. I hope to see you soon, and until then, goodbye.
Goodbye.